Hello again. Welcome back to designing your uilleann pipes in Fusion 360. Today we're going to deal with the Chanter, or we'll start dealing with the Chanter. The one you see on the screen is loosely based on Wilbert Garvin's 1978 book, The Irish Bagpipes, with dimensions and designs roughly based on his work. And what we're going to end up with is the timber body of the Chanter, various ornaments, the cap, and the strengthening ferrules, as well as taking decisions about what size the tone holes are going to be and where they're going to be put and what size is the internal bore. So all sorts of great fun ahead of us. So we're not actually going to work with the Wilbert Garvin data. We're going to go to open source data designed on the concert pitch Chanter in the O'Flynn Rowson plans that are housed with the NPU, and we're going to roughly base the data on those. Here you see one of the drawings. Now the data in the O'Flynn Rowson plans show tone holes that are not quite circular, and they show a nidder bore which is not a straightforward conical taper, but we're going to ignore that. We're going to go with circular holes roughly based on the dimensions of the NPU plans, and we're going to work with a taper that approximates, is the best word I can use to describe it, that approximates the data as shown in the plans. So we're going to end up with a design that looks like this. A very simple, straightforward design focusing on the timber body only. We will come back and add in the rest of the components. And we're going to, once we have the design complete, we're going to do 3 drawings. One is just simply an overview. The second one then is, when you fit it back on the screen, the linear dimensions, showing both all the diameters and the lengths and various pieces. And we're going to show as well the inner bore and the reed seat. And finally, we're going to do a drawing showing the locations of the tone holes with respect to the bell end and the diameters of the circular tone holes. And we're going to do 7 on the front, left hand and right hand, and we're going to do back D, and we're going to put in place a C natural on the basis that if you're making a practice chanter, it's often the habit to put in the C natural hole and plug it with a small piece of cork against future need. Okay, so with that in mind, we'll start off. So I'll just close that. We'll close that as well. And we will get the data panel out of view. So this is what you should be looking at, or something close to. Now, before we actually start, I want to remind you that there's a link to a set of written instructions down in the description panel, and there's also a link to the actual design and the drawings down there as well. Okay, so it's worth your while getting all of those and having them to hand before you start. So we want to start with new design. Now you're in new design already. It's unsaved, and the first thing we want to do is to save it. Now I'm going to call it Demo Chanter Body. You make up your own name for it. And finally the cloud wakens up and it names the file. Now, I'm not going to start drawing immediately. What I'm going to do first of all is I'm going to modify. Oh, no. Right click on it, new component, and I'm going to call this timber body. Now, as we go through this, I'll try and explain the relevance of things like components and bodies. They all have their own meaning in Fusion 360, and over time you will get used to them. But the key thing is that if I set this up as a component, then down here at the bottom of the screen, the history of what I do with this component will be available along a timeline here, and it's very powerful for letting me go back and revisit what I do. Okay, so I want to make sure that the timber body is active. That little black dot, make sure he's clicked on. It might be that that one is active. You don't want that, because anything you do now will start to go against that component. So you want to make this component active, make sure that black dot is active, or that dot is active. Okay, so first thing we want to do now is we want to create a sketch. We want to pick our plane. So depending on where the mouse goes, one or other of the three available planes gets selected. So I'm going to select that one. Now, if you're unsure as to what plane, just finish sketch. Now, there's nothing in the sketch, but you can see how the sketch now is starting. There is a sketch in existence, it's just nothing in it. So I'm going to just delete it to get rid of it. And if I want now to create a sketch again, show the origin, you can see that as I highlight each one of these, the sketch becomes slightly, or the plane becomes slightly grayed in the main screen. So I usually go with the YZ plane. And there you have it. This thing here in the middle is what is known as the origin. And you can see you have an axis there, and an axis there, and a plane there. And you can move around with the little cube in the top right hand corner. But for the purposes of working with chanters, so much of the work we do is circular on the YZ plane and linear on the x-axis, that it's good to look at the actual workspace square on. So we're going to build a circle. So this is going to be the read end of the chanter. So this is the very top of the chanter that you'll bury into the cap when you start playing it. And the dimensions for this is 14.8 millimeters. So we've just created a circle. This is your sketch palette over here, palette. Finish the sketch, and you can see the way it turns nicely. So the next thing we're going to do, if you haven't met it before, is this chap here, which in the notes is create extrude. Now the shortcut key is just to hit the letter E on the keyboard, but because we have just created a circle, Fusion figures out that we want to extrude or extend that circle. So this is going to form the neck of the chanter that's going to be buried up into the cap, and you take a view as to what length you want that to be. So you can see the numbers here. So I'm going to type 25. I've lost focus there, so just delete that. 25 millimeters, and you can see it has shrunk back to the proper distance. It's showing the number there, and it's showing a number there. You can move the sled around if he's in your way or you can't see it. You can also move this chap around. Now I'm going to pop him onto another screen entirely out of the way, if you're lucky enough to have several screens. So once we have the extrusion parameter entered, we hit OK, and there we're good. Now, we want to put a little bit of a stopper, I call it, at the bottom of the neck. And we do a very simple one. Go back and we create a sketch, and we actually use this face as the construction plane. This practice can cause you trouble later on, because whatever you put onto that face, if you change the length of the extrusion, it will travel with it. So you need to be aware of that in other projects. We're going to go with another circle. Now make sure you get the cursor onto the center. And if you look closely, as you come towards the origin, you'll see you get a little blue square. That lets you know you're on the center. What size do we want this? Well, I go with 25 because it's a round number. It's as much an aesthetic decision as an engineering decision. It's just there to give you a resting shoulder against that'll stop the cap sliding down entirely over the chanter. So finish the sketch. Now we're going to have to give that a little bit of thickness, and we're going to use the extrude again. Now you need to be careful here, because extrude or Fusion will recognize that there's actually two profiles in there. That one and that one. So an inner circle and an outer, an inner circle and an outer hoop. So we want both. Now you don't have to hold down shift there. A click on one, then followed by a click on the other will give you both. And then we persuaded we want to go in that direction. Now I picked a distance of 4 millimeters for that. Now, not the prettiest thing in the world, but we'll come back later on and make it pretty. Now, again, we're going to create a new sketch, and we're going to take this face as our construction plane. We'll make a new circle. Now we're going to go back and rely on the data we have from the NPU, and we're going to pick 17 millimeters for this circle. We'll finish that sketch. Now we're not going to extrude that circle. We're going to do something entirely different with it. We're going to build two offset planes. And we're going to offset them off this plane here, which is the YZ plane. See the YZ on the left? That turns blue when I highlight that plane. So I'm going to construct an offset plane. I'm going to pick that plane. Now I'm going to put in another plane, which is 357.2 millimeters away from that. And that gives us the full length of the chanter to be. That's the design length of the entire chanter. But I'm going to need another construction plane, and I'm going to use him as my offset plane. I'm going to say, right, construct an offset plane, and I'm just going to go back. And this is going to give me the distance, or the point at which the external taper of the chanter ends and the reinforcing ferrule begins. So I'm going to make him 45.5. No. You'll make this mistake heaps of times as well. I left out the minus. So there he is. So I'm going to construct now the tapered external body from that circle here to that plane there. So to do that, I need create a sketch on that plane. Okay, so now go for the circle. It looks as if it's all going on top of itself, but it's not. This circle will actually go on that plane, which is negative 45.5 from the bell end of the chanter. It's often a good idea to make the circle real big, way bigger than it's actually going to be before you type in the numbers, and the numbers for this are 20.4. This is purely a matter of aesthetics for you. This is the external taper of the chanter. It will have some effect on the chimney depth of your final design. For the moment, 20.4 is going with the plan, and we'll finish the sketch. We'll just take a look at everything now, and you can see the way that this circle is well away now from this one. So we now need to build the body between that circle and this one. And the way we do that, well, firstly, we want to make sure that those sketches are visible. You might have this situation and you can't see anything. And if they're not made visible, you can't get at them. So when you're going to do a loft, it's important to make sure that the sketches are actually visible. And we're going to create a loft. And up comes the dialog box and inviting us to pick the profiles we want. That lad. So we got him. We have success. He turned blue. And we have this one. And now you have a loft created between the two. It's important to pick the operation join. There are other ones available. We will use them later on. But for this one, we want it to join. That makes this loft part of the overall body that we're building. Hit OK. So you can see the chanter starting to come together. Just move on again. Now, on this construction plane, we're going to create a circle this time I went with 15.5, which is a little bit bigger than the NPU plan, but it leaves more material in the finished chanter, and we'll finish that sketch. You can see we have the new circle here. Now we're going to grow this chap into a cylinder back to this point, and we're going to use extrude to do that. We're going to convince him to go that way. Now we know that the distance is 45.5, but we might decide to change that at a later stage, and we don't want to put a parameter in here that locks our extrusion to 45.5. So we want it to go to the object. And object is selected in the dialog box. The arrow is pointing away here. This is the object. Now it knows currently that it's 45.5, if you can see that in the screen. But it knows it now is bound forever that anytime we change where that plane is, change the length of that loft, the length of this will change as well. Save you all sorts of grief in the future. Now you can see we have the external body. So next thing we want to do is we want to tidy up this lad here. Oh, it's just have a look at him. Now the simplest way to tidy this chap up, there's several ways for building ornamentation in Fusion. We created a circle and we just extruded it. That gives us a cylinder, and we're going to modify that cylinder with a fillet. Now if you can't see the fillet in your icons, go to modify, it'll be down here. And likewise, if you wanted to use a quick shortcut, you can use the letter F. We'll go with fillet. Now you don't have to do them one at a time. You can pick a wodge of them together. So we'll select that edge and we'll select that edge. Again, you don't have to hold down shift. It asks you what dimension you want. Now I'm going to break this. I'm going to call it 2.5. Oh, it did it. Shouldn't have done it. You can see the way I would expect that to throw an error, but I'll just go back to 2. Because it's 4 mil in depth, when you put in a fillet of 2, you actually turn the outside of the cylinder into a semicircle. You get a nice hoop effect. Okay, other ways for doing it, but that's a simple way for today. So where are we now? Just have a view of everything. So you've now completed the Chanter body timber solid. Now you won't get much music out of it until we do a few other things with it. And the first thing we're going to do is we're going to put in the inner bore. Now we're going to take a very simple approach to that. We're going to put in an entry hole up here for the reed seat. We're going to put an ending circle for the reed seat, which is the narrowest point of the inner bore, and then we're going to put a circle in here at the bell end. And you can do this in any order you like. I'm just going to start off now as we did it in the instructions, and I'm going to zero in here. If you don't like these things, just hide the origin. There they are. They're still available, but they're gone away, or they're hidden for the moment. And we're going to put in a circle on that face. And that circle is going to be the opening diameter of the reed seat, and a 7.1. We finish the sketch. I'm going to show the origins again, because I'm going to create a construction plane, an offset plane. And I'm going to make it, I think it's 20 millimeters from that. That's the depth of the reed seat. And I need that plane to create a little circle on it. So I'm going to create a sketch again. And circle, I just hit the letter C for the tool. And I think we make this chap 5.5. Let me just check on my notes. Yeah, 5.5 it is. Oh. So 5.5, and we'll finish the sketch. I'm just moving through my notes now. Okay. Now we're going to do another loft. Now I've moved him up there the way because I use loft an awful lot. Now the way I do that is I will go to loft and get the little 3 dots there, click on that, and I have them pinned to the toolbar. Okay, so now I'm going to pick my 2 profiles. Again, if you can't see the inner sketch, take a look and make sure your sketch is visible. We pick him, we pick him. Now you see the red showing up in the inner board. That means that Fusion has decided that you probably want to remove or cut material. And that's what we want to do. And you can see the nice conical shape that it has. And we'll hit OK. Now, we'll zoom in again, and this time we'll go and we'll take a look at the other end. And we want to put a circle in there. Again, making sure that the circle tool is on the center, little blue square. And I have to check the data for this one. I think it's 13 point something. Yeah, 13.2. Enter. And we'll finish the sketch. And you can see that the other sketches have disappeared. The last one is still visible, but I want him. And when I hit sketch 8, now your sketch might be numbered differently depending on the order of which you did it. So I want to go loft. Now you have to be careful here. You can loft from a point as well as from a circle. Now you may want to zoom in so that you're sure you can select him. See, if I select that, it'll loft from that point, which will give me a very strange effect. But I want to loft from that circle to the other one. Now you can see I have the lovely red cone in the heart of the Chanter. So I'll hit OK. I'm going to go home and look at front. I'm going to show you something here. You want to check that. Have we everything right? And a good place to go is to inspect. And down at the bottom you have section analysis. We want to pick a cut plane. Now, you see the flip? You might want to hit him to actually show the midsection. Hit OK. And now you have brought in an analysis group into the workflow. You can see we have a nice reed seat and we have a nice taper all the way to the end of the chanter. And if we want to see the whole body again, we just hit that eye there. The analysis disappears, the cross section disappears, and we can go back to it at later stages to actually check on further work. Okay, so that completes the simple inner bore with an evenly tapered air column and an evenly tapered reed seat. Doesn't resemble a whole lot the actual data as in the plans with the NPU, but fairly close. So the next thing we want to do is we want to put in tone holes. Now, we just hide the sketches. So we want to put in tone holes on that plane there. So we're actually going to draw them down the center plane. I think it's the XY. Yeah, it's the XY plane. So we're going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9. 7 on the front and 2 on the back, tone holes. So we're going to make a sketch. Now, there are many ways for doing this. So I'll show you the first one. And put it anywhere. So we'll make this the E hole, and that's 7.05 in diameter. There it is. It's a long way from the chanter, so we want to get it into the chanter. See that chap there? Horizontal and vertical. Pick him up, click on him, and go back to the origin. So he's now horizontal forever, locked into it with the origin. And we want the dimension to be, so I move to the bell end and I pick up that dark line. I move the cursor up. I'm now going to set the distance, and the distance I have for him is 56.9. Okay, and he's nicely positioned. I'm just going to pause the video now, and I'm going to put in the rest of the holes in this sketch rather than wasting your life watching me do that. But I'll just do one more so that you'll see it. The next one is 5.4. This is the E flat hole. And we're going to make it horizontal with the origin. And we're going to give it its dimension. Which is 87.5. And there it is. Okay, going to pause now, and I'll be back with you in jig time. Okay, so I'm back, and here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 perspective tone holes created on the, just escape out of that. XY plane. Okay, there's all my dimensions in, so I'll finish the sketch. Now, some of those tone holes, I want them to pierce through the front of the chanter. So to do that, now again, if you can't see them, make sure the sketch is visible. So we want to do this. Now, he's the back D. He's the C nat. So we want them to go this way. These lads getting in my way. Click, hold, pull them out of the way. As I click on each hole, you can, or each circle, you can see how it turns blue. If depending on your screen size, your extrude dialog might be in your way, just haul it out of the way. So we want these to come up this way. Now that'll work, but the best way to do that is just simply to say, go through all. We hit OK. We have the tone holes at the front. We don't have the tone holes at the back. And what happened to the other tone holes? What happened to all our little circles? The sketch is not visible. Turned itself off once the extrusion was over. We want to extrude again, but this time we want him, and we want him. We want him to go that way, and we want him to cut, not distance, but all. See, he's going the other way now. And that's okay. Now we can hide the sketch. Have a look at the front. Now we'll turn our analysis back on. And that's what you hope to see. The even tapers, the tone holes all in position, and everything in line. Back D, C nat going out the back, and the other 7 tone holes coming out the front. Everything else waiting in place. Okay, I'm going to finish this video at this stage because it's long enough, and I'll come back with a separate video where we turn this chanter into a set of drawings. Okay, talk again soon.